Welcome, welcome, welcome to each and every one of you to the Soil Summit 2024, our live Q&A with David Johnson and Hui-Chun Johnson, founders of the JohnsonSu Bioreactor. And I see there's some people in the chat who've already said, we use it, we built it, we use extracts, and it's amazing. So welcome to people who are already familiar with David and Hui-Chun, and we are in for a treat. We are in for
no pressure, Natalie.
Pardon me?
No pressure, please.
No pressure, no pressure. Okay, well, I can just say that one of the things that I love about the work that you do is how clearly you simplify numbers and data so that the average person who might not be familiar with science can have a better understanding of what's happening in our soil, in our compost, and in life, and within our own human ethos. You do a beautiful job of connecting the dots for us,
Yep.
and for me and for other people who I know have seen your work. So I am deeply grateful for that. So thank you.
Well, you're welcome. I have to give a lot of the credit to Hui-Chun. She's my translator.
Well, I'm so curious, how did the two of you discover that you had this love of soil and compost and
Dirty laundry.
dirty laundry? Yeah, I should figure that out. What was the moment?
Well, I think most people that their life journey is analog. You go through life, you pick up certain things, you realize certain things along the way, and then before you know it, then you realize that, well, we got into certain areas so much more, and then we just got so much more curious, and then we want to know more about it. So it wasn't like an epiphany at one point that, oh, we just love the soil. And I think as David probably told many people, that he was a builder contractor for 30 years, and then he went back to school and got his molecular biology degree, and he became a researcher. Coming from a different background, he did not look at the information, the science, the same way of just something so little in front of you. He looked at it as something as part of the system, as part of the community and everything. And so when we first started the JohnsonSu compost, it was a project. He was working at a university, and I'm not related to university, and I'm not a PhD. And so he was following what everybody else did with the windrow compost, and then things weren't working out very well. And at the time, we also very fortunate, and the name came up several times. That was with a different speaker as well, is Dr. Elaine Ingham.
Mm-hmm.
I mean, she really kudos to her of spearheaded down this biology paradigm of thinking about the system. And anyway, that David taken one of her workshop, and she was so gracious to allow me to sit in for a couple mornings. I think it was morning or afternoon. Anyway, but she was so well articulating what needs to be there, the aerobicness of the compost, and also the water, and also the living microbes. And so that gave me some idea to work with David, because David, he's already a molecular biologist. Mm-hmm. And so he knows a lot more about that. But when we started to change to static compost pile, that we were able to utilize some of the teaching from Dr. Elaine Ingham. And then, we started thinking about, well, we may not be particularly profound, but I think we have a few knowledge we can put together. And then we, little did we know that this JohnsonSu composting system will be something that is able to incubate so much microbes and to become a fungal dominant aerobic compost.
And it was always anomalies. In the research, of course, you have a path or a goal that you're trying to prove, a hypothesis, but it was always the anomalies. Well, what's happening? Something's happening different over here that shouldn't be happening. And it was that path that we followed that finally ended us up into this design on this composting process, and also in the application as well.
Yeah, and back to the dirty laundry part. Windrow processing requires a lot of hands-on labor work, and David came home with lots of dirty, stinky clothes. And I confess, I'm a terrible housewife, and that mountain tall pile of dirty laundry is not my favorite. So it's okay that we want to work hard. Let's try to work smart. And that's where it came into that picture, because the hate of doing laundry, dirty laundry, and then we came up with something that we don't need to turn. And we came up with something that actually, I guess, out of desperation, that sometimes we starting to have the innovation, and we start looking through all the knowledge that we have learned and borrowed from everybody else, and then what can we make the connection of all the information and put it together. And we were lucky. I mean, there are a few trial and errors, more than a few, but we didn't just get it right away, but we were on the right path.
And we're still on that path. As I said before, we're all students in this and learning day after day. And it takes all of us looking at it. It's so complex. It takes all of us looking at this to see what works where and when.
Yeah, so true. I was going to ask you what was part of the inspiration for going towards a static pile, and but you answered that. I'm curious, what were some of the unexpected breakthroughs?
Oh, well, in most of the composting processes, your fungal to bacterial ratio is relatively low. If you get a really good compost, when you're looking at fungal hyphae, 3-to-1 is pretty good result. Now, what we were seeing as you go through the composting process and you allow it to mature that year, fungal hyphae are gone. The fungi have exhausted the food resources in that pile, and what do? They sporulate. So we have lots of spores, and when you look at the fungal to bacterial ratio in our compost, it's as high as 625-to-1. That's why it can be applied at 2 pounds per acre or 2 kilos per hectare and show results, because you're putting about 4 to 5 million fungal spores a square foot and about 90 million bacteria per square foot into this system. So it's a different compost than what you normally see, either windrow, especially windrow. The only reason we have the fungal community is because it's undisturbed.
And
that allows, go ahead.
Can you help us understand why that's so important and what that major difference is? So, for example, how much would a thermal compost pile, how much of that would you have to apply to an acre versus how much you're applying to an acre, and what the difference is in that fungal ratio?
Well, they view the compost made in the windrows a little differently. It's a nutrient amendment. They gauge it on how much nitrogen, how much phosphorus is in that compost. At 2 pounds per acre rate, which we apply, that's negligible, if even at all. And it's more the biology that you're putting into the system. Joe said it right this morning. It's all about the quality of the compost. And we're seeing, there's a certain maturity that has to occur in this process. And we've noticed, looking at metagenomic studies, that it takes about a year to get there. There is a common endpoint in the quality or the structure of this compost that we see. If it's made in Australia, it's the same end product, the same microbial community structure in it as what we're seeing here.
And for those of you who like to take notes, here would be something to write it down, is that this is a 100% aerobic composting system. So that means that the air infiltration rate is very, very important. This is also incorporating with vermicomposting. So in a good condition for the worms, for both the worms and also from the fungi, from what I read, is somewhere around 70% moisture content. So do keep your moisture content around 70%. And no turn is so important. And from like what I said earlier, I was so lazy to do laundry. So we don't want to turn anything. It's too much labor, too much work. But because coming out of that laziness, we found out that by not turning anything, that we were able to allow the fungi to flourish in this composting pile. And you should see David. I wish you all could see that. I wish I had a filming of it. The day after we put it together, and then he went to check on the compost bioreactor, and he came back in and he said, "You wouldn't believe this. You wouldn't believe this. I mean, the fungal hyphae and the mycelium totally grew through the pile and stabilized the pile. I mean,
like overnight
in one day. So after 24 hours, we were able to pull all those air pipes out of there, out of the bioreactor, and then the entire surface area of the pipe becomes the surface area for the air infiltration. And that is the part that I kept wanting to tell people, that this is about incubating the biological inoculant. And that's why it's able to inoculate the land at 2 pounds per acre rate. So you want to see, that's why I also wanted to impress upon people that if you decide to do this, follow through all the instructions very closely and get 1 or 2 bills successfully and have good results before you innovate. By all means, after that, innovate. But it's like baking something. If you've never done it before, you wouldn't be able to really understand all the principles, why those principles need to be adhered to. So just keep it in mind, it's 100% aerobic. So air infiltration rate is very important. 70% water, moisture content, and no turn. So, and another thing, don't let it freeze and don't let it dry out. That's another very important part. And because the microbes will form this hydrophobic layer if you allow it to freeze or dry, then you will have to take it apart, shred it, and redo. You don't want to do that. And you will see fungi of some sort coming and going throughout the 1 year. We've had people say they saw something hot pink, something white, something yellow, something look like regular mushrooms, just different type of fungi. They will come and they will go. And but if you have anything of a plant species growing out of this pile, that means that your moisture content is not right. This is a very aggressive environment for composting. This is not organic matter to put it on your soil. So if you have plants growing out of it, that means that something has gone wrong.
Well, also remember, I saw a couple of questions on temperature. We've seen it get up to 160 degrees Fahrenheit. Normal is about 140, and that lasts for about 3 to 5 days. And it's done with the thermophilic phase completely because you've kept that moisture in. And part of the success of this is we do clean organic matter. We do put it through a bath to get all the dirt and the rocks out of this. It's good to take the time at the beginning to put a good batch together, because one of these bioreactors, you put about 2,000 pounds of wet material into it. You'll get about 700 pounds of finished material. And with that, you can do 350 acres. You were talking about the application rate of regular compost. It's up to 20 tons per acre or more in some cases. It's not practical on a large scale, but this, if you're doing, this will do 350 acres with one bioreactor.
If you have a good quality compost.
And temperature is not an issue. I've had them never go over 80 degrees Fahrenheit. But as Hui-Chun was saying, it's such an aggressive environment. It has that moisture content. You put the worms in after the thermophilic phase, if you have one. And it's pretty much a vermicompost.
After that.
And the results we see in the field are leading us to believe that, you know, this is a very powerful mechanism to rebuild and restart that soil microbiome.
But David had looked at a vermicompost and compared to ours, there are structure differences there. So it's not just vermicomposting. And whatever y'all do, if you're going to try to do JohnsonSu compost, or if you want to try Dr. Elaine Ingham's composting process, or Bukashi or whatever, adhere to each individual composting system's instruction. Don't mix them up, because each system they develop for certain reason that to allow the system to mature or to encourage certain type of microbial community. So if you take a little bit here, a little bit there, you are more than likely to violate some of the basic principles for those systems. And so just keep that in mind. You know, we never pretend to think that there's only one way to get to a right place. But, you know, but try to have a certain amount of discipline to observe why some people, their system is successful in doing what way and what principle attached to that.
Yeah, I deeply appreciate you voicing that, because when we were first talking about having this conversation, one of the most important pieces from your observation is observation and noticing what the systems are. And I'm just wondering if you could speak a little bit more to that, because, and yes, we will put a place where you can get the JohnsonSu bioreactor instructions. We'll pop that into the chat. And going back to that observation and systems, can you help us understand why that's actually the most important part of composting?
What was it again?
Why observation, or how observation is actually the most important part of the journey, or one of the most important parts of the journey of composting and building and compost?
Well, besides for making mistakes as the best teacher, it can be calamitous. But if you're an observer, then you can start putting these pieces together. And it's so important if you're a farmer, anybody, any occupation you have, is to observe what's going on around you. What you did this happens, or you did this and that's not supposed to happen.
Yeah.
And it's the one that's not supposed to happen. That's the path you're supposed to follow.
Why and how, and what should I do to follow up on that? And for example, that when we developed this JohnsonSu composting static system, that we knew it's supposed to have certain moisture content. We knew it's supposed to be aerobic, and we knew what we wanted to be no turn. But in the center of the bioreactor, excuse me, it became anaerobic every time. And so then we started thinking about if it needs to be aerobic. And sometimes if you just take a step back and look at the whole thing, and you realize that certain density of a materials, the air infiltration can only go so far. And that's when we start thinking about, oh yeah, maybe if we put some pipes in there to increase the air infiltration. So that's why we tell people that roughly about 1 foot in diameter of a distance, or not diameter, distance from where you can start having the beginning the air can infiltrate, then you're pretty safe that your pile is going to stay aerobic. And then, of course, then we're realizing that nature is so awesome. And then the fungal hyphae grew through the pile in one day, and we could take those drain pipes out of there. And also, another part is that do use the material that we recommend. I mean, the construction material, because it's very important that this bioreactor will be very heavy when you put it together. I mean, when you fill it. So you want to have something stable and substantial. So that's why we use the 6x6 wire mesh, so it can stand upright, and it can also stand up for 12 months. Also using the woven landscaping cloth. There are it's about 5.4 ounce material, and that is because that it allows the air infiltration rate to be proper, but also keep the moisture content consistent in there, because you want to have the system that is uniform. You don't want the outside to be drying out. And then so a lot of this little things, just if you follow the instruction, pay attention, observation, observation, observation. As you go through the journey, you're going to pick up all these little cookie crumbs, like what we did. The nature kept dropping little cookie crumbs for us and allow us to realize, oh, that's why it was doing this or that. And so yeah, observation, there's no replacement for it. We can figure out different type of engineering innovation as a tool for us to utilize, but they cannot replace you as a living being in the system to manage your system.
So I see questions here about maybe making a pile and turning it and then put it in the JohnsonSu bioreactor. Unless you just have nothing else to do, I think it's wise just to go ahead and build it. If you're worried about weed seeds, they won't survive except for tomato. Tomato seeds seem to survive anything.
At least for our experience.
Pathogens, pathogens is a real big question here. When is a microbe a pathogen? It's usually when it's in an environment that it's not supposed to be, that we've created, that it gets out of hand. But you will see all kinds of, every pathogen known to man in this process. When I do metagenomics on it, even the black plague, Yersinia pestis, is in that compost. So we're going to have to start looking at this a little differently as what is a pathogen, when and where. And as far as the pile getting hot, I think they're probably worried about having it be approved. And I think what I've seen, most composting regulations will allow a vermicompost that's gone a year. And they will consider it, everything is good in that pile. Now, unless you're in California, and if you have earthworms in there, they consider that manure, the worm cast as manure, and they won't accept.
We read that somewhere. It was a
compost.
little bit far-fetched. I don't know if they have modified it or not, but somehow worms will consider livestock. So
Yeah.
somebody let us know if in California it's different now. It has been a while when we read that.
There's a number of people that are familiar with the JohnsonSu bioreactor, and there's some people that it's brand new to. Can we just back it up a little bit? Because we have the thermogenic piles, which we're heating up and we're turning multiple times and we're keeping them at a certain heat. And we have the static piles where we combine different materials and we leave them sit for long periods of time. And we have that maybe what you're talking, maybe that was the windrow you were talking about as well. Windrows can sometimes be turned as with a compost turner. And we have the biodynamic compost piles, which are mixing and layering multiple different materials, and those are static as well. So tell us exactly, what is the JohnsonSu bioreactor?
Well, we're a little less specific than the dynamic one. We use just about any material. Leaves, hay, wood chips, if you have a really dense pile, like you're putting a lot of manures in it. But you want it to be able to breathe. You want the particles small enough that they'll pack well, but they'll still allow air to flow through. What we found out in windrow composting is anytime you're more than a foot away from ambient air, the pile will go anaerobic. So the way we design this, it's up on a pallet. Air can flow up underneath it, up through the little chimneys that we put in with that pipe. The pipe are only in there for 24 hours. And we pull them out, and you have airflow up through the center. So in pile, you're never more than 1 foot away from ambient air. So that keeps it aerobic. Keeping the moisture content, as Hui-Chun was saying, is critical. We water it daily for about 1.5 minutes with those split spot sprayers, and that will keep the pile normally wet. If you're in a really dry environment, sometimes I'll put another perimeter hose there to put water on the edge, but the worms will eat all the way to the edge of that container, and you'll have just about the pile starts out at 5 foot tall. You'll end up at about 2.5 feet tall, or about 2 feet tall, and it will be nothing but vermicompost. It turns out like clay. You don't recognize any plant-based material in this compost.
Yeah, I always tell people that at the end, it looks like a very decadent, moist, dark chocolate cake. And then when you squeeze it in your hand, and you actually have ribbons come oozing out between your fingers, and feel like it's like a Play-Doh or clay at that point. So to do it right is very important. The first pile we put together, it had 1/3 dairy manure, 1/3 wood chips, and they're very tiny wood chips, like 3/8 and less.
3/8, yep.
And also yard waste. But everything went through chipper shredder, and also went through a water bath process. And we do have David's YouTube channel does have the video for it. And so those steps are very important. If you skip that step and not doing it properly, not doing the water bath part, allowing the sand and dirt, different material and rocks to settle out. Just think about if you're using 2 pounds per acre inoculation rate, and a lot of that weight, the mass coming from sand, dirt, rock, you won't have the efficacy. So be very conscientious about going through the water bath part of it. But then lately, we've been using just purely leaves, or sometimes when
Moldy hay.
When people are moldy hay, they're just going to burn it.
It's not a waste. It's gold.
We composted, and it turned out beautiful. So this is a value added. This is a circular use of your source materials on your land, in your system. And so we've been using pretty much just what we can, but
it's not the content you put in so much as it's the process.
Yeah.
It's allowing nature to do what she does. It's allowing her to go through each phase and each step of that biodegradation and break it down for the next organism to be able to break it down. And that's why we think it's so successful in its use. Is you've gotten down to what nature was going to put there anyway through the worms. We're just trying to mimic nature as much as we can. And you're bringing in, like Joe was saying, you're bringing in nitrogen fixing bacteria, both symbiotic and free living. You're bringing in phosphorus solubilizers to free up the phosphorus in the soil, because they've applied so much phosphorus in these systems. There's 40 or 50 years of phosphorus, but it's not available because the microbes haven't made it accessible to the plant. We're seeing microbes involved with quorum sensing. It's when you start to build your soil microbiome, quorum sensing it's like us as a community. One person cannot accomplish a whole lot, but working in a community together, they can accomplish things that the single person can't. And that's what happens in quorum sensing. They all get together in a community. They start to put out different signals. Each one will pick up. They'll be able to transcribe genes that they couldn't as an individual, make products that they can't as an individual, but they can as a community. And that's what we're trying to restore, is that the system dynamics.
The synergy, that the system, when it's healthy and balanced, and they are able to actually utilize each other's talents and then build off each other. And it's very important part, because too often just by ourselves we cannot do certain things, but somebody come in and let us use their tool, and all of a sudden we have another skill set we never even knew that we have. And so those are very important part about having enough diversity and population in those microbial community structures to enable for them to get to the stage of collaboration and cooperation and creating that synergy.
Let me give you an example of what we're observing in Turkey. We got a cotton project over there in 2019.
Mm-hmm.
And of course, cotton, it's the worst crop on the soil of any crop. It's the dirtiest crop as well, as far as pesticides and herbicides. These people had 22 passes across the field for fertilizers, herbicides, pesticides, tilling, weeding. And we brought in this system, what we're calling BEAM, Biologically Enhanced Agricultural Management. They started using it the first year, the cover crops. Year after year after year, we built cover crops from about 400 grams of dry biomass per square meter up now to 925. So we've over doubled the productivity of a cover crop in that system. They have completely gotten away from herbicides. Pesticides, they've reduced by 65%. We've reduced nitrogen use in that system by 85%, and still pull in a good crop. They're actually $1,300 a hectare more profitable in the system. Normally, what you see in our agricultural systems, they're lucky to build up soil carbon at 0.02% a year. Okay, we're building it up at over 1/3%. We're putting in 8.02 tons of carbon per hectare per year into this system. And the normal is less than half a ton. So we're about 15 times higher soil organic carbon accrual in this system. They're, as I say, they were more profitable by $1,300 an acre. Their soils have completely changed. What they noticed is the worms came back.
Mm-hmm. Yeah.
And they had not seen worms over there since they were kids.
The biodiversity, the bird population, all this indicators in a healthy system. When the wildlife, when the biology can come back on your farm and wanted to stay there.
That last cover crop was over the tires on their tractor, them trying to roll it down. But they planted into it and the cotton crop came up right through it. So this is a real game changer,
yeah,
as far as farmers restoring the fertility of their soils, because that's exactly what they're seeing. You can tell when you walk over the soils, it's completely different. It's spongy, it gives.
Yeah. And another thing we didn't mention was that they use 2/3 of the water that they typically have, and still able to produce crop. So there's a lot of a potential that we don't know until we are able to allow the nature to do her wonder. And so, this is just like what we said before, the result came out much better than what we expected. And, David had to go back and recalculate and recalculate and recalculate to make sure that
This can't be true.
make
This
sure
can't be this much carbon.
make sure he did not make a mistake somewhere.
When you look at this, if we bring this into half of the arable land, all anthropogenic CO2 emissions will be offset just through farming correctly, using the microbes. It's a no-brainer. Food quality will go up. You'll be able to reclaim lands before that are just totally destroyed because, you know, we've done this in the desert. You know, we didn't have anything much to work with when we started the project, and we live in the desert here. So all we had were sandy soils. So there's a lot of potential here, bringing back that soil microbiome, bringing it back, both the functionality of it, well, the structure of it, the diversity of it, and the biological functionality.
And I do have to bring it back to emphasize that BEAM, BEAM, stands for biologically enhanced agriculture management. So for the JohnsonSu compost, using it as inoculant, that is just a fun part of it, the biologically enhanced part. But the agriculture management, that is so important to support all those helpful, beneficial microbes to help you farm and have a production, is so important that appropriate agriculture management need to incorporate the cover crop as much no-till as possible, because as we know, if you have too much disturbance, you pretty much break up any kind of a possible improvement for fungal community. And that's the part about our composting system that was successfully to incubate higher fungal profile, is because it's no turn. Because I often tell people that if somebody come into your house and toss everything you ever own out of there every day, let's see how well you survive and establish. Not very well. And it's the same way if you go in there and you stir up all the fungal hyphae and then break everything up, exposing all these microbes to air and dry them out, desiccating them, they are not going to establish very well. And that's the important part. It also goes back to the observation. If you're not there to see how things degrade, how things improve, you wouldn't know at what point that you were doing right or you're doing wrong. And that's very important, because sometimes people are just looking at the JohnsonSu compost bioreactor as just a mechanical contraption, just a shape or something. And when they try to modify in their own ways, they neglect to look at the principle that's very important of that system. And then too often their efforts will be in vain because they fail. So it's very, very important to observe and watch the progress and see why and how things happen, so you understand why those principles are there.
There was one question there about, can you just keep putting material in? No. Fill it up and let it mature. Start another bioreactor or save the material for another bioreactor, but let it go through the process. Another question on there, Anson, is the microbiology the same depending on the raw material? One of the bioreactors that we did in the test in the Metagenomic was made in Australia. They use eucalyptus leaves, very toxic. We just used regular hay or alfalfa or leaves here. The biology was identical.
After we have the sample of both. Well, we look at analysis, metagenomic and metatranscriptomic analysis for both compost that was made in Australia and the compost that we made here in New Mexico. And the amazing part is that we're at 4,000 feet above sea level, high desert, northern hemisphere. And David used, I can't remember, was it all leaves or alfalfa, moldy alfalfa. Anyway, then Dr. Terry McCosker in Australia, he used what's available there is eucalyptus leaves and twigs that he found on his property. And he's in Southern Hemisphere. He's in subtropical climate, right next to the ocean. So this is totally different setting, totally different environment, totally different input material. And yet the metagenomic analysis came out almost identical. That totally make us surprised because we were worried about the eucalyptus part. But that's the thing about when you experience different things like that and not having any kind of expectation. And then to find that out, so it makes us think that perhaps nature have some kind of common endpoint if you allow the nature to do its thing.
Yeah, what about using the JohnsonSu bioreactor in colder climates, like -40,
But
-20
you
degrees
don't want to
Celsius?
let it freeze.
So what do you, have you seen it being done successful, and
Oh
what
yeah,
do people do?
we've seen it in Quebec at -45. They put it in a hoop house where they had aquaculture. In another place next to it, they started an anaerobic composting process. They used the heat out of that to heat the aquaculture place and keep the JohnsonSu bioreactor from freezing.
The inside of that hoop house.
If you have cows, put it in the barn with the cows. If you have a shop, it's movable. It's on a pallet. If you have a forklift or a tractor with forks, you can move it in. You can put a heat tape underneath it and insulate it.
But not -40 though. Yeah.
Maybe if it's inside a barn or
But
something.
whatever you do, and I know that people who live in colder climate, they will have a lot better idea about how to innovate, about how to keep things warm. And we live in the high desert, so too often our thinking is how to keep ourselves cool.
Right.
Treat it like your favorite child. Don't leave them outside to freeze.
And have you researched or looked at biodynamic composting methods? And if so, do you have any insights you could share with us?
We really are not expert in that field whatsoever.
I've always had an interest in looking into it, looking up, just having the funding. These metagenomic tests are not inexpensive.
Yeah.
And it takes a little while to analyze them. But, I'm not saying this is the only way to make it. We have also tested some proprietary processes in Australia making vermicompost that have almost exactly the same structure as well. So this is not the only way. This is one way.
Yeah.
And if you're doing this at scale, you need to have something that you don't have to invest a lot of time in, that you don't use a lot of it to get coverage and get that biology reclaimed. And I don't think you're going to have to use this forever after you bring these soils back. I mean, I was looking at what Joe said about having soil organic content from 3% to 5%. All I ever get to work with is 0.5% or less. Our soils are really broken.
Most of them are.
Yeah, most of them are across this planet.
Yeah.
But if it works here, it can almost. We think it can work almost anywhere. And we're seeing a lot of farmers. Corey Miller in Montana, when he put it on a cereal rye crop that he was growing, he had 40 acres without. He did one pass with the biology. Where he didn't have the biology, the cereal rye was from 8 to 12 inches tall. Where he did have the biology was from 4 to 5 feet tall. And a difference between like 6 seed heads on a plant compared to maybe 1 on the other. So the dynamics are starting to show with farmers using it. It's practical for them. It's profitable for them. But most importantly, it starts to bring that soil fertility back.
Yeah, you're bringing the very talented group of microbes when you do the inoculation. And they are your underground farmers. They're helping you supply some of the micronutrients in there that it exists, they exist in your soil, but the plants cannot take it. And they help, some of them even making phytohormone and cellulose. It's amazing about the different type of microbes you have. So it, again, you have to think about diversity is very, very important. And I use this analogy, sports, baseball. You need to have somebody that can hit really well, but you also need to have first, second, third base, catcher, pitcher, infield, outfield, shortstop, everybody. You don't have those people. Some of them might be standing around most time during the game, but you need them there. So when the ball flies out there, somebody's there to take care of it. And that's the thing about the diversity, is that when you have the diversity and population of the microbial structure, that you allow them to work together and to collaborate and cooperate to create a synergy and working as a winning team for you. That's the way I look at it. That's how I visualize.
Mhm. And we're washing everything that goes into the bioreactor composting pile. Why would we wash moldy hay?
Okay. We're not so much washing as we're trying to, any dirt or heavy particles will settle out. We're just trying to also rehydrate the material, because your moldy hay is going to be pretty dry, more than likely.
Yeah.
And if you run it through a chipper shredder, that kind of opens it up. That's good for the process as well, because that allows the microbes to degrade the material from the inside out.
Yeah.
And it goes faster. The more the material is broken up.
Yeah, when we do the water bath, it's just basically, when you put a tub of water and then you put the material in there, make sure you don't overfill it. Make sure your material it's able to float. Then you get a pair of rain boots on, go in there, do a little bit. I love Lucy's thing, stomping around in there. Just kind of stir it enough that the dirt and sand and little rocks will settle to the bottom. We're not saying that this has to be pristine, but it needs to be clean enough. You don't have to scrub it, of course, but it's just that you don't want to have a lot of mineral stuck to it.
Makes sense. And what about, how do you apply the 2 pounds per acre?
We'll make an extract. It's I have a video of a poor boy extractor that we have online, and you just basically I have a 5-gallon bucket on top of a 55-gallon bucket, and it's got a paint screen in it, and I get a hose and I'm recirculating water with an agricultural pump, and I'm spraying the compost, rinsing off all the biology, and just time after time. It only takes just a couple of minutes to make the extract, and then you have something that you can dilute depending on how much compost that you rinsed off into that 55-gallon drum, and you can dilute it, put it into your nurse tank on your tractor, and feed it through injection system. That's the best way. Second best is coating the seed with the extract. And if you can, plant it damp. So usually the seed will flow pretty well damp, and getting it into the soil as quick as you can. But it's having that, like on the extract, spraying it into the furrow at planting, so it gets soil seed contact. And we've seen great germination rates on this. Year after year, you start, as I say, building up that soil biology.
I just want to point people towards the interview you did with Dr. Lane Ingham's The Soil Food Web, because you dropped so much great data and science in that presentation you did. So we'll share the link. I'll try to get it in the chat here for people to go check out the science. I just dropped some of the numbers to my son, and like I said, he's 18, by the way. I said, did you know that Humans are made of 10 trillion human cells and 90 trillion microbial cells. And so I just started to drop all these numbers, and he was so interested that he actually went and watched your video.
good.
Wow.
Yeah, it was
Very
really
impressed.
cool. And just, I mean, there's so many things in it, and I'm wondering what is most inspiring to you about what you're learning about microbes and fungi and bacteria, all the things.
It's, you never figure it all out. There's always something there for you to keep searching after.
It's
Keeps you humble. Keeps you looking at the complexity of this system, how with our mind, our linear mind, how can we understand a dynamic system? There's so many things that happen in every direction. It's fascinating.
But you know,
Every day.
the inspiring part for me is that we live on this living planet, and looking at this living, complex living system, it's so mind-boggling, but yet so elegant and so beautiful. And at one point it feels overwhelmed, but at certain point you're just starting to resign to the fact how amazing it is. How amazing it is. And I don't need to, or I shouldn't be arrogant enough to think that I am going to know everything about it. It's okay that I just keep learning, and I just keep enjoying the journey of learning, as long as that I do pay attention and observe and follow the cookie crumbs in Mother Nature drop for us.
Another thing is to see farmers, see a smile on their face.
I know. It's awesome. It really is awesome. They are this special group of people in our heart, for sure. And, it's hard work. It's most definitely hard work. And you don't always have the payoff that you put your hard work into. And yet they go in there season after season, year after year, and doing the work. And so, hats off to them. And
now they have a system that they can start seeing the improvement in their soils. Most of the farmers came to the point that they just almost gave up. They didn't want to pass their land on to their kids because it was nothing but a headache. It was not that profitable. This turns this totally around. Now, being able to restore that fertility to the soils, restore the productivity to the system, and restore the longevity of the system as well.
Can you just give us an idea? So 2 pounds per acre, that's not a lot. It's not a lot, right? And so how many pounds are we of that rich, gooey
Chocolate cake,
that goes through our fingers when we squish it, are we coming out with after we build one of your?
about 700 pounds. So that will give you 350 acres of coverage.
that's why quality is so important.
Yes, yes.
Quality, quality, quality.
As I was saying, on the fungal to bacterial ratio, I'm completely 2 orders of magnitude greater than anything you see in a normal compost. I mean, 625 to 1 compared to maybe 3 to 1 in a good compost.
And can you speak to some of someone asked about the species of fungi that you're seeing? Can you speak to that at all? It sounds like we might be here for millions of minutes.
We see about, oh gosh, a little over 3,000 total species. At the beginning, it's very dominant with the fungi. Let me see if I can pull this up or not.
While you're pulling that up here, I have some more interesting facts from your presentation. You said microbes are the backbone of every organism and ecosystem on this living planet, which I just loved. And then there's 800 million viruses And they my notes are a little bit rough here. And they modulate the function of all things. And is it
Oh.
800 billion viruses fall in every square meter of the earth every day?
Yes, yes.
It blows my mind.
And they completely consume, in the ocean, they completely consume almost 40% of the bacteria every day. So the bacteria are reproducing. The dead bodies are being assimilated by other organisms or settling down to the ocean floor.
And that's another thing to think about on this living earth is
Mhm.
everything is in some phase of cycle. So nothing is static. And to think that things are going to stay in one condition, it's futile.
Mhm.
Let
Yeah,
me
it's
read you
so
this.
dynamic.
Can you see this, the metagenomic analysis chart?
Yes.
Okay, these are about 14 different composts that we compared the structure with. We had them all over New Mexico, Colorado, California, Montana, New York, Texas, and then we had 3 from Australia and then 2 of mine. You can see all of those, they were mature. They had gone through the 1 year, they had gone through the process. I think this one froze, these got dry, different things happened on the way. But you can see with the principal component analysis, they're almost identical. When we put those same compost in that order, we start to see the dynamics of change through this system. You see at the beginning, Ascomycota, Chytridiomycota, some of the fungi are very dominant in this system. And as you move this way, they seem to disappear in the system, but then you start to see acidobacteria appear on the scene, actinobacteria, plantomycetes here in the orange, Bacteroidetes, chloroflexi here in the green, cyanobacteria. As you see this maturity from right to left, these composts over here are mature and they're functional. They work in the system. And the fungi, this is the odd part. It's about 98% bacteria at this point. But if you go into the fungal community and look at the diversity, there's more diversity in that 2% than there is in the 98% on the bacteria side. So these are little things that we find out as we go that we do not expect. Hope that was helpful on that answer.
Yeah, very helpful. People are just loving your answers and your reflections. What else is there here? What is your opinion? Oh, what is your opinion of bugs in a jug? Shelf-stable bio-amendments products.
Well, you have a choice, and the bugs in a jug are maybe up to 12 or 17 microbes. Usually it's 2 or 3. There's very few in there. When you look at what you're putting out with the compost, you're probably putting out 100 to 200 times the number of organisms per square foot that you are with the bug in the jug. So when you're talking, was it 4 to 5 million fungal spores per square foot that you're applying at that 2 pounds per acre, you probably don't have that many in that one jug that you're going to apply to several acres. So there's just no comparison.
So if anybody who is curious about any of those products, then perhaps they ought to do a trial on their own. Just do a little test plot and see how the seeds germinate, see how those plants get to the maturity, and just do it on your own to see how it turns out. If there's actually any kind of efficacy and does it have a long-term effect, if the root system have been improved or not.
The cost for this would be about $2 an acre. And you're going to be paying a lot more for a few bugs in a jug.
Yeah.
And we're not saying that none of them are good, because we are not involved with anybody, and so who are we to say that none of them they're good. So just do your own homework. But we do know that there are quite a few of them. They are really terrible. And we just felt bad for the farmers that we tested one product and we're just appalled for lack of anything
Didn't see
in there.
anything.
Yeah. So and time again we realize that the farmers it seems to get taken and they spend the money that they could have been putting into other places on the farm. And so, again, we're not knocking any of those companies selling product. If you're curious, do your own homework.
And that's another thing about our perception of things. We always look for that silver bullet, that single thing that will fix this. Nature's not that way. Nature uses a community, a system to reboot everything. So you don't know what helper bacteria are needed for those bacteria that you're putting in. Yet you seem to get everything in the compost.
So fascinating. There was a question that came up here that I wanted to pop in with. Oh, the home gardener. Do you have a smaller system model for the home gardener or not?
2.5 feet, put one pipe in the middle.
Oh, although you will never have enough of this. You can grow straight into it. It's not like some compost that they'll burn the plant. I've gotten 80 pounds of tomatoes off of one tomato plant in this stuff. So, and on your garden, you need to treat it like what we're treating these fields when we're starting to bring that bean management back in there. Grow cover crops into your system. The cover crops are your winter cover crops. They will, when you get ready to plant, just tamp them down. Have them go to the soil service for surface residue and then plant into them. That way you'll be rebuilding. It's like that first slide that Joe showed. This is about energy. It's very similar to what we see in our society. If we don't have energy, we're cavemen. We're barely surviving. Add a little more energy, we start to get reproduction. A little more energy, we start to get diversity or different talents. A little more, you start to get synergy. People working together. Look what we can accomplish as a community when we have enough energy in the system. It's the same in the soil. And we've been robbing this soil of that energy, not having as much plant growth on that system as we can get to get that energy flow and all that carbon flowing down there to feed those organisms so they can rebuild their community as well. And it's so simple and so easy. Once you start looking at it this way, that I'm actually farming microbes. I'm not farming plants, I'm farming microbes. And those are the ones that make the plants grow.
But plant roots are very important.
Oh yeah.
They work together, the microbes and the plants.
This is all about synergy too.
Yeah. It's not just like what you say, it's not one silver bullet. You have to look at it as a system. And how do you make this system work better for you?
Moj, I apologize if I didn't say your name right. They came across an article that said synthetic nitrogen fertilizers or fertilizers increase the population of the wrong kinds of actinomite.
Yeah.
What do you think about that?
Oh, everything we've done, all the fertilizers we've applied, nitrogen is really bad. It probably does that, but most importantly, it burns out carbon. And you cannot build your soil carbon up by adding nitrogen fertilizers. And I saw that in our project in Turkey, where we had 3 different treatments: no nitrogen, 15% nitrogen, and 100% nitrogen. And 100% nitrogen, the soils had lower carbon, but they also had lower nitrogen. So adding these fertilizers, it just robs the soil of the carbon and the nitrogen. Now, in Turkey, we saw the nitrogen increase in these soils. We were seeing 662 kilograms of nitrogen per hectare, or about 500 pounds of nitrogen increase in this system. Now, normally a crop only takes less than 200. So that's what they will apply. It usually takes less than that. But we're putting in over twice the amount of nitrogen every year once you bring the biology back into this system. So nitrogen will no longer be needed in our agri ecosystems.
Yeah, because when you have this biological system is functioning, then you will have the players in there fixing the nitrogen from the atmosphere into the root zone to help the plants grow.
And also utilizing the cover crop you grew before, it's on the ground, it's being degraded. The roots and the microbes are breaking it down, offering the nitrogen to the roots of the plant that's growing currently.
So again, it's a whole system thing. It's not just one thing. And so there's another part people need to keep in mind is that nitrogen cycle, carbon cycle, and water cycle, they're also very well intertwined. So if when you get a better carbon cycle and nitrogen cycle, you're going to get a better water cycle in that system too.
I think in the previous one with Joe, there was a question about what do you see in macro and micronutrients? And they did a quick study looking at once you start applying beam, what happens to the availability of those nutrients? Magnesium or manganese and iron, 1100% increase in availability over a 20 month period. All your copper, gosh, I can't remember. Let me show you the chart. Go ahead and talk.
That would be awesome. Maybe you can answer this question while you bring up the chart. Do you ever incorporate any Korean natural farming or natural farming strategies in your work, collecting indigenous microorganisms from the natural ecosystems and introducing them as additional diversity to your compost?
Well, we see them. This compost is made when we first started in Las Cruces, New Mexico. I saw microbes from the Antarctic, microbes from the Arctic, microbes that in the ocean with pelagic. And I don't think
and keep it in mind,
necessary to bring anything in. It's already there on all the leaves and everything you're bringing in.
Yeah, keep it in mind that we did not have the type of budget grant resource to import fancy microbes with calculation. And so that is another part about observation is when you observe that and you realize that, wow, everything could be everywhere.
That's fascinating because you did not bring those microbes in even from the first. They're already there.
We can't afford it.
Yeah.
So so that's the part that we have to be open-minded about, that when people try to think that localized environment, well, how local is it? And so that's up to debate, but we pretty much just utilize what is most available here, what we can utilize, supposedly waste, but to us they're resource.
Can you see the chart?
You can, thank you.
Okay.
There's a little square at the very top. I'm not too sure what that is. If you can see that on your screen, it's right. Yeah, it's just above the 20-month study and sampling, 5 sampling periods.
Okay, let's see. How do I get rid of this one?
We can mostly see it. So
we can't get rid of it because it would stop sharing.
Yeah.
That's okay. That's
But,
the new thing. Just leave it. Yeah, you can see.
What this was when I first started using Beam, I wanted to know what plant available nutrients, what happens to them as this process goes forward. We saw 1100% increase in manganese and iron, 83% increase in plant availability of magnesium, calcium, zinc, and copper from 83% to 40%. We also build up of macronutrients. We're growing a crop here. We should be extracting this, but these nutrients are building up in the soil as you are still making a crop. And the interesting thing about this is in our soils, we have very high pH, about 8.2. Iron and manganese copper and zinc should all be decreasing in availability in this system. But with the right biology, these things start to reappear.
That's so cool. I just want to speak a little bit to the natural farming, bringing indigenous microorganisms in, because one of the things I've heard in this conversation is observation and following the system is probably one of the most important parts of practicing the JohnsonSu bioreactor or any composting. So what would be curious is for if you wanted to look at bringing in a handful of indigenous microorganisms or put some IMO or IMO4 into that composting process with the bioreactor, is to first do the JohnsonSu method from start to finish and then experiment with it afterwards to see how it actually does impact the outcome of what you are ending up with.
Or side-by-side comparisons.
Yeah.
Right.
Yeah. Yeah,
Good
do your own observation, you will experiment that way, so you know what actually works for you in your environment. And even that's why we never say that, okay, do exactly what we do here, because everybody have a little bit different environment, different seasonality. So as you are applying in your system on your farm, that you need to tweak a little bit according to your own seasonality or your environment. For example, over here, we only water the compost bioreactor 1 minute a day, minute and a half a day. But for people who live in the environment that rains every day, the air is very saturated with the moisture. Perhaps they don't need to water as much. They still need to water every day, but just not as much. But then for places where they are so much drier and hotter than we are here, then perhaps they need to water more. So there's certain tweaks that you need to do, but without observation, you will never figure out when you need to do what.
And since it is a material that's been rinsed or washed, you don't have the dirt in there. It's all organic matter. It will never waterlog. So you can overwater it a little bit. If it flows out the bottom, you can back off a little bit, but it'll never go anaerobic on you. That's the nice thing about it.
But you don't want to waste the water or making a mess, so you want to adjust it right.
Also, you could go to a natural area around you, like go up to the forest, get some of the duff off the forest floor, and throw that into the rinse water. That will inoculate.
And I will emphasize, not the soil, not the dirt. The duff means the kind of degraded organic matter, like maybe some kind of partially degraded leaves and things like that, but not the soil, because too often people say, oh, we went to the forest and got some of the natural soil out of the forest. No, you don't want to throw any more soil. You don't want to throw soil in there.
Yeah, that makes a lot of sense. Do you have the slide handy where you show the cotton farm that you're working with the different trials for people to see?
Oh, there wasn't a lot of difference visually. The nitrogen fertilizer didn't really show anything. There was no correlation with soil organic carbon or nitrogen in that system. Let me see what I can find here.
And I just want to clarify that when we talk about fungal to bacterial ratio, that's in mass. That's not it.
And is there a specific composting method you'd recommend for households who go through a lot of food waste?
Well, what we usually do it on our food waste, I have a solar dryer and I save it all. I'll chip it and shred it and put it in the next compost pile.
But we know that some people, they use vermicomposting for
Mhm.
the kitchen waste. Seems to be a good way to do it.
So it sounds like you dry it and then you chip it and then you use
Yeah.
it. You could
Yeah,
also
'cause-
puree it and then freeze it.
Well,
We don't have enough freezer space. So and that's a lot of moisture that need to be dried out before we compost it.
Right.
So where we live here in southern New Mexico, it's very easy. Just David built a contraption that has plexiglass on the top
Uh-huh.
and screen in the bottom is a wood frame, and he opens up on the top and then toss those I don't know, fruits and vegetable scrap in there, and then they dried up in no time, and he just keep throwing those pieces, dry pieces, in the 55-gallon drum until he collects enough to be part of a bioreactor again.
this is what we were looking at in Turkey.
Mm.
Originally, this is what they did, 20 trips across the field, as I was saying, for planting, fertilizer, herbicide, insecticide. We cut that down by 65%. This is what the cover crops look like. Here, as you can see, they're legume dominant, about 80%. We roll them down and right before spring planting, and then we plant into that. Let's see. And then here you see cotton seed coming out. On the right hand, you can see how that forage starts to degrade, keeps the soil covered. They don't have the weed problem. They can use 30% less water. That provides a microclimate of
Environment.
increased CO2, so the plants grow better. Just many things. As I was telling you, it was 85% reduction in fertilizer, nitrogen, 100% in phosphorus, 100% reduction in herbicides, 56% in insecticides, 61% in diesel use, and then 35% reduction in water. So it had a dramatic impact on.
Okay, I just want to go back to what David talking about, the increase in CO2. What happened is that, can you see the arrow on the screen?
Yep.
Okay, because when you wrote down all this organic matter here, and then as they degrade, of course, they're going to also put out CO2 as well, as they get basically through the degradation. However, through this plant canopy in this level, that the plants use the CO2 for the photosynthesis. And so it gets gobbled up. So that's why when we're talking about system approach, is that when you're designing and changing your practice to regenerative agriculture, you need to look at what you do as a system. And in this case is that you do the cover crop, and you do the no-till row, you do the row down, no-till drill in your cash crop here. And then this degradation of the plants provide the environment for the beneficial insects
And earthworms.
but also some of the nesting birds as well. But also the degradation of this organic matter also provide the extra CO2 at this canopy level for your next crop. And so this gets recycled. Everything gets recycled here. It's a beautiful system.
And you always have about 20% of the carbon in that left in the system. So you start to rebuild the soil profile, and you also rebuild on top of that soil surface. So year after year, you're growing more soil into this system. Another mechanism for pulling carbon out of the atmosphere and putting it back into your land.
Becomes more stable carbon in this system, having a longer residence time as a soil, part of a soil, instead of in the atmosphere.
The farmers are so happy with this. They bought 2,000 hectares in Romania, and they're employing the bean process there.
Wow. That's exciting. It's really cool. Well, just one more quick question. Is that okay if we do one more quick
Sure.
question? It's popped in a few times. And Ethan's wondering if you've done any experimenting with electroculture in combination with your composting.
What kind of culture?
Electroculture. It's
We don't
in
have.
life-
here you go. You can watch Yannick Van Doorn's session in the Soil Summit, and he's been studying electroculture for the last 20 years. It's fascinating. And I would be fascinated to know any research that is done in combination with the composting of JohnsonSu. So Ethan, if you do that, let us know. And maybe you'll be presenting at the Soil Summit next year. Wouldn't that be cool?
Yeah, we need to learn more.
Yeah, there's so much more to learn. I'm popping David's interview, his webinar with the Soil Food Web in here because I just think it's so fabulous for people who like to dive into numbers and science, and it really complements our conversation that we've had here today. And is there anything else that you wanted to share with us that we haven't touched on today that's important or that's on your heart?
Try it.
Yeah. Stay curious.
Yep.
And have the discipline to follow the principle and understand the principle. And then if you really learn from all that, then it's time to innovate.
Yep.
And when you have innovation that have a good result, then share with everybody. Then we all can move forward together.
And what does biodiversity mean to you?
Life. That's
Yeah.
how we survive.
And cultivating life, what does that mean to you?
Oh gosh. Well, good food.
Be at peace with nature.
Pardon me?
Be at peace with nature.
I like that.
And
Beautiful.
realize you're part within nature too.
Yeah, we are.
That you're a part.
We are part of system. Too often people talk like as if we are not part of this living planet. We're not part of system. We are part of system. And how
Sure.
do we make a good partner of this system, having ourselves in it? And that's a question people should ask all the time. Don't remove yourself from the system because you are not removed. You do have to live with the consequences.
Thank you. Thank you so much for coming on and sharing that story and that inspiration.
Yeah.
I deeply appreciate you. And our hearts and our love is with each and every one of you as we stand together and deepen into this space of possibility and dynamic connection, and really deepen into connecting with our hearts and our soil and how we are part of nature and a part of this beautiful planet Earth. So with that, I will invite you to the next session, which is Ernest Ghost, and he is known for syntropic farming, and it's also a conversation, and he's very, very passionate and very, very excited to share about the intelligence of nature, because that's what all of his work is based on. And he's got some wonderful stories and some wonderful insights, and I look forward to seeing you. Look forward to seeing you there. How can we support you, David and Hui-Chun, moving forward in your work?
The word out. Educate these farmers. The life can be so much better for them and for us.
We're always fundraising, of course, in able to do more research, because there are often a lot of people saying that, well, why didn't you try this? Why didn't you try that? But time and money, like what everybody else has to face. But for most part is that if you have a question and it's within your ability, then you can do a little trial. You can be the citizen scientist. You can be the farmer scientist. You can be the garden scientist. Just do the little trial and then write down what your observations are. Don't forget that observation, and then share it with everybody.
Make a YouTube video and send it out to everybody.
Just make sure that as you're making the JohnsonSu compost bioreactor, adhere to the instructions. because it takes it takes a lot of work at the beginning, and it takes a whole year to mature. So we don't want somebody to wait a year just to fail. So it's just make sure that, have the discipline to adhere to the instructions and then get it done right. And then we hope that you're successful. And then you can go on and, excuse me, and go and teach others to be successful.
Beautiful. And this is their YouTube channel. So you can go and find them on YouTube and subscribe to their channel and watch some of their work.
Thank you.
Yeah, thank you. Thank you, David. Thank you.
Thank you as well for the opportunity to share.
Oh, such a gift to have you, such an honor to be in the room with you and to share just a small part of your journey. So you reach out to us anytime we can amplify something for you, or if you have something that more people need to learn about or know about, let us know so we can share it in our newsletters and share it with the community.
I'm just about finished with the manuscript on Turkey. So once I get that published, I'll send you a link to it.
Fabulous. Sounds really, really good. We'll make sure to amplify it for you.
Thank
And before we wrap up, we have one calendar, a celestial planting calendar to give away. And Leslie, you roll the numbers. Who's
Good,
like
of course. So the Celestial Planting Calendar is a wonderful guide of how to use the cosmic influences to really increase yields and support your harvest. So we can use it very simply by following the charts. But you can really dive into the astronomical information. And so, Chris Armitage, are you still on the call here? Chris Armitage. Our email is connect@heartandsoilmagazine.com. Email us. It is a physical product, so we would like to send it to your home or workplace, wherever. I'll put that in the chat. Oh.
And there's lots of thank yous for coming through for you both. People really enjoyed your session today. Thank you for the knowledge and experience. Thank you so much. Thank you. My dad is one of your biggest fans, by the way. He
Say hello to your dad.
he thinks your research is and some of the best out there, and the numbers that you share and the way that you share it. He speaks so appreciatively of your work. So I just wanted to let you know that. Yeah, he was here today too, making some comments about different things and asking questions. Yeah.
Hi, Nally's dad.
His name is Hans. He's going to be part of this summit as well. So a long-time organic and biodynamic farmer. And then we have Robbie Gass here, who's also a long-time farmer, one of our presenters from yesterday. So it's really nice. Thank you for joining the community.
Thank you for the opportunity.
Thank you. And thank you all for being part of this. And thank all the farmers and gardeners and everybody who grows things.
Yes. Bless you.